Welcome. Today's presentation is on conducting a simple regression test. My name is Moise Isunga. The agenda. I will start with defining what is a linear regression. Then we will conduct three simple regression tests. Then we'll have a takeaway of my presentation, an annotated bibliography, reading summary, and we will end the presentation by taking questions. A linear regression is a basic and commonly used type of predictive analysis. The overall idea of regression is to examine two things. Does a set of predictor variables do a good job in predicting an outcome variable? Which variables in particular are significant predictors of the outcome variable, and in what way do they impact the outcome variable? The first regression test was conducted. Can we predict an individual's death by knowing their income? The following regression hypothesis was conducted. The null hypothesis. There are no significant regressors. The alternative hypothesis. There is at least one significant regressor. A simple linear regression was conducted to determine whether individuals' death can be predicted knowing their income. No significant regression was found, with beta equal minus 0.05, r square equal 0.00, p equal 0.535. With the rejection rule, we reject the null when p is less than alpha, where alpha equals 0.05. Here p equals 0.53, that is greater than alpha, thus we fail to reject the null hypothesis. Therefore, there is no significant regressor. The second regression test. Can we predict an individual's savings by knowing their income? The following regression hypothesis was conducted. The null hypothesis. There are no significant regressors. The alternative hypothesis. There is at least one significant regressor. A simple linear regression was conducted to determine whether individuals' income could be predicted knowing their savings. A statistically significant regression emerged with beta equal 0.91, r squared equal 0.82, and p equal 0. Thus, the test rejected the null hypothesis and predicted portfolio value, where savings equal 0.91 times income minus 203.47. Savings is predicted to increase as income increases. Further, the 95% confidence interval between 0.09 and 0.11 does not contain zero, hence lending support to the prediction. The third regression test. Can we predict an individual's portfolio value by knowing their savings? The following regression hypothesis was conducted. The null hypothesis. There are no significant regressors. The alternative. There is at least one significant regressor. A simple linear regression was conducted to determine whether individuals' portfolio could be predicted knowing their savings. A statistically significant regression emerged, with beta equal minus 0.38, r squared equal 0.28, and p equal 0.022. Thus, the test rejected the null hypothesis and predicted portfolio value, where stocks equal 0.28 times savings plus 1006.73. Stocks is predicted to increase as savings increases. Further, the 95% confidence interval between 0.07 and 0.25 does not contain zero, hence lending support to the prediction. The takeaway: we can say that the null hypothesis testing is a formal approach to deciding whether a statistical relationship in a sample reflects a real relationship in the population or is just due to chance. The logic of null hypothesis testing involved assuming that the null hypothesis is true, finding how likely the sample result will be if this assumption were correct, and then making a decision. We can use PSPP to conduct a regression analysis in order to identify the relationship between a dependent variable and one or more independent variables. In simple linear regression, the model used to describe a relationship between a single dependent variable y and a single independent variable x. Regression modeling is a tool for predictive analytics. The annotated bibliography. We only have retained here 3. The textbooks, the readings from Creative Commons license on research methods in psychology, another reading on correlation. From the readings, we have retained mainly 3, but we have read more than that. In the textbooks, what we have learned is that we have learned the fundamental definition and different types of research: applied research and basic research. We have gained general understanding of what constitutes scientific research and examine the hallmarks of scientific investigation. From the Creative Commons license, we have found the true purpose of null hypothesis testing, including the role of sampling error. Also, we have learned to describe the basic logic of null hypothesis testing and also describe the role of relationship strength and sample size in determining statistical significance and make reasonable judgment about statistical significance based on these 2 factors. From William Troshim, we have learned that the correlation is one of the most common and most useful statistics. A correlation is a single number that describes the degree of relationship between 2 variables. Thank you for listening to my presentation. Now we are open for questions.